Welcome! In this video, we will design a top-down excavation with diaphragm walls and concrete slabs in DeepEX software. Initially, we will access and edit the slab section's properties. In the corresponding dialog, we can adjust the slab section thickness, reinforcement, and materials. In the speech area on the left side of the screen, we write the following command. Create a 28 feet deep excavation with slabs, and we press enter. DeepEX will generate the model automatically, including all construction stages. We can access each generated slab on the model area and apply the desired slab section. We can also apply user-defined unbraced lengths for the slabs. In this case, we will apply 20 feet unbraced lengths for each generated slab. We will access the wall and select to edit the structural section. In the Wall Sections dialog, we select to use reinforced concrete diaphragm walls, and we can adjust parameters such as the section thickness, as well as the longitudinal and shear reinforcement bars. We access the right wall on the model area, and we can adjust the wall position. In the Soil Types dialog, we can review and edit the soil properties for different soil types. In the Borings dialog, we can create the stratigraphy by defining the top elevation and soil type for each soil layer. In this example, we will use a fill soil, a medium dense sand, and undrained clay, and a glacial till. We can edit the water table elevation in all wall sides. We can select to maintain the water table at the excavation subgrade between the walls in all stages. We can do manual edits to the generated model. In this case, we will change the excavation elevation to -30 feet between the walls. We add a new construction stage, and we will draw a base slab. We select the corresponding tool and click on each wall. In the dialog that appears, we can define the elevation of the center of the slab. We select the option to include the slab weight to the vertical stress, and we will define a small unbraced length of 1 foot. Initially, the limit equilibrium method is selected for this model. We make a copy of the design section and apply the nonlinear analysis method with soil springs. We can access the base slab and change the connection of the slab with the wall to pin. We will also apply as wall friction 66% of the soil friction angle for both walls. We add a new copy of the model and apply the finite element method. We select to analyze all 3 design sections. In the Analysis and Checking Summary table, we can see the critical results for each method and have a direct comparison. In the Model area, we can display different result graphs for each construction stage for each method, including wall moment and shear diagrams, soil pressures, horizontal displacements, support reactions, and more. In the FEM model, we can display the generated FEM mesh and all displacements, settlements, and stress shadings on the model area. Thank you for watching this video. Visit our websites and find out how to overcome your geostructural challenges with our programs.